So today we move from circles to ellipses. Definition of an ellipse is the set of all points whose sum of distances from 2 points is a constant. And if you look at the diagram that I have below, you can see that the 2 points we're talking about are some interior points to that ellipse. And the sum of the distances, call this distance x and y. The sum of those two distances is going to be constant anywhere around the circle. And the way to draw a perfect ellipse is to take, if you will, and put like 2 nails in a board or on the ground, or just fix 2 points on the ground, attach a string between them of any length, and then if you hold that string taut with a pencil and trace around, you'll get a perfect ellipse all the time. You can see this in this diagram I have below here. It'll bring up a little diagram of that, and here are the 2 fixed points, and now I have this taut string pulling around and around, and I draw a perfect ellipse every time. So, and here's our cross section, slanted cross section of a cone, and there's my ellipse figure. So in general, our ellipse is going to look as such. In all ellipses we have 2 axes of symmetry, if you will, and it turns out that at the end of each of these, you're going to have vertices. So I have a vertex here and a vertex here. Now some books call the points at the end of the other axis of symmetries vertices also. And it varies from book to book. I prefer to call these, which a lot of books also do, covertices. Now the axis that all vertices are on is called the major axis. And the length of a major axis is given by the length from vertex to vertex. Now, as noted here, the length from the center, which we're going to call HK in terms of a translated axis, is the distance A. So the major axis has a distance of 2A in length. We call this other axis, which the covertices are on, the minor axis. And as can be shown from the center to a covertex, that has a length of B, so that has a length of 2B. And then the distance to this center point, or from the center point to this focus, and that's the 2 dots in between we use to draw the ellipse from, this distance here is C. And there's no special name for the focal axis or whatever, but the distance from the center to a focus is called C. Now if we look, if I have a horizontal major axis, in other words, my vertices are this way, then my equation for my ellipse is x minus h squared over a squared and y minus k squared over b squared. If I have a vertical major axis, in other words, the vertices are going vertically, then I have x minus h squared over b squared and y minus k squared over a squared is equal to 1. The way I remember this is, first of all, the vertices are always further spread apart than the covertices. So whichever side is longer, that's going to carry the distance of A with it. All right. If it's horizontally longer, as in this case, my A value is under the X. If it's vertically longer, as in this case, my A value is under the Y. All right. Now, there's a relationship that also exists between A, B, and C. It turns out that for all ellipses, a squared is equal to b squared plus c squared. In other words, there's a Pythagorean relationship here where this is a squared, and it creates a nice right triangle. All right, so the first task for the day is to draw a sketch of this ellipse. Now, I know this is my h value, this is my k value, and since my bigger number is under the y, I should be having a vertical major axis. So let's just draw a sketch of this. Here's -2 and 7. I'll put a dot right there and call that my center. Now, since this is a vertical major axis, and I know my a value is 5 and my b value is equal to 2, I move up and down 5 from that point. So if I go up 1, 2, 3, 4, 5, put a dot here, go down 5, put a dot there, over 2 puts me on this axis, and over 2 puts me somewhere over here, and now I create this oblong figure. And again, it's just a sketch, doesn't have to be super accurate, but that's my ellipse. In order to sketch it, I don't need to draw in where the foci would be. Foci refers to two focus values. Next thing I want to do is I want to find the center, the foci, and the vertices for this ellipse. Now you'll notice again, my a value, since 36 is bigger than 16, is 6, and my b value is equal to 4. My center is -2 and -5. So to do these problems, I kind of like to sketch out what's going on here. So I'm going to take and go to -2, -5. Put a little dot there. And I know that since my bigger value is under the x, this is going to be a horizontal major. So it's going to look something like this. All right, so that means I have to move over 6 in both directions to get to my vertices. So if I move over 2, 3, 4, 5, 6, that puts me right around here, and 1, 2, 3, 4, 5, 6 puts me right around here. So my vertices are 6 to the left and right of this point. So that would be -2 plus and minus 6 over to the left and right, and -5 down, which puts me at 4 and -5 and -8 and -5. Center, we already said, was -2, -5, and now I have my vertices here. The foci, I need to find my c value to get that. Well, I had that relationship between a, b, and c where a squared equals b squared plus c squared. Well, I have a squared, that's 36. I have b squared, which is 16, which leaves me to find c. I end up with 20 is equal to c squared, and 2√5 equals c. Now, turns out that my foci are always on the same axis as the vertices. So really, I need to move over √5, 2√5, sorry, 2√5 in length to find my foci. All right, and that's moving left and right. So to find the foci, once again, I'm going to start at -2, because that's my center, and move to the left and right, so that's adding and subtracting 2√5 and I'm still down 5. And I can leave that as such. I don't need to put it in decimal form. Now we're going to kind of go backwards. We're going to be given some information and asked to write the equation. So I'm asked to write the equation of an ellipse if my vertices are at 0, 7, and 0, -7, and the minor axis length is 6. Well, I know the minor axis is equivalent to 2b. That's equal to 6. So my b value is 3. That's going to help me a little bit. If I want to take and do some sketching here, 0, 7, let's call it here, and 0, -7 would be here. And these are vertices. So this ends up being my major axis. And my center then would be in between those two, or my center's at 0, 0. Because it's halfway between the two vertices. So therefore, x minus h is just x minus 0, or x squared. Y minus k is also y minus 0, or y squared. And as in all ellipses, those are always equal to 1. Now I have to determine where my vertices are. They're vertical, so my bigger number, my a value, has to go under my y. Well, I know the a value is 7. So a squared is just equal to 49. And since it's vertical, it goes under the y. And b we've already determined was 3, so b squared is 9. And thus we've written the equation. Next example. Again, we've got some vertices given, and this time we're given our foci. So let's sketch this out again. I have a point at 1, 5. Call this 1. Call this 5. Another one at 1, 13. Call this 13 here. And these are my vertices, which means it's going to open vertically again. So my major axis is vertical. And then I have foci at 1, 7. Call this 7 here. And 1, 11. Call this 11 here. As such, which means now I've got to find my center. And the center is going to be halfway between the 13 and the 5. Well, between 13 and 5, I have a total of 8. So halfway between that is then 4. And 4 up from that 5 point gets me a 9. So now I know I have a center at 1 and 9. Which then tells me the start of my equation is x minus 1 quantity squared plus y minus 9 quantity squared is equal to 1. Since it's vertical, I know my a value will go under this term and my b value will go under this term. I can find a from the picture because I know the distance a goes from my center to my vertex, and from 9 to 5 I have 4. So my a value is 4, my a squared value is 16. I now have to find my b value, and I can do that from simply using my a, b, and c relationship. I know that c is equal to 2 because that's a distance from the center to one of the foci. So now I know that if I have a squared equaling b squared plus c squared again, and I know a squared is 16, I'm looking for my b squared value. We've already said our c squared value is 4. B squared is then equal to 12, and I can put that value right here. So my equation is given as such. That's all we've got. And get on these problems. We'll see you tomorrow.